You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Abiotic Oil. Today we're going to trudge through the frozen forests of Siberia until we come to a remote, ice-encrusted oil derrick. It's sucking black gold from super deep, deeper than any other wells on Earth, pulling up petroleum consisting of 100% hydrocarbon fuel, free of the chemical signatures that characterize all other oil on the planet. It is abiotic oil, oil that came to be through means other than biological. Conventional understanding is that Earth's oil and other fossil fuels come from ancient organic matter, metamorphosed by time and pressure and heat into a hydrocarbon fuel source that we're burning through quickly and will eventually run out of. The hypothesis of abiotic oil, on the other hand, states that it comes from natural geological processes, which are ongoing, and thus we will never run out. Interestingly, this science claim is almost always intermingled with conspiracy theories accusing the oil industry of pretending that oil supplies are limited in order to keep its price high. This is the complete rundown on abiotic oil. In episode 100, we talked about peak oil, the belief, possibly true, that we have already recovered most of the oil that can be feasibly pumped out of the ground, and the corollary belief, certainly not true, that at some point soon we'll suddenly run out, and it will become an overnight worldwide disaster straight out of Mad Max 2: The Road Warrior. Conversely, the abiotic oil hypothesis suggests that we'll never run out. It's an idea that appeals to a support base from the conspiracy theory crowd, as it suggests that all the world's fears surrounding oil are unfounded and foisted upon us by greedy corporate interests. We're going to talk about the science of this now, but notice how the story will circle back around to ideology by the end. The hypothesis of abiotic oil holds an interesting place in earth sciences. Most geophysicists will agree that it is plausible for some amount of hydrocarbons to arise from natural processes. That plausibility exists within very limited bounds, because all of the oil we've found so far has been fossil fuel, metamorphosed from ancient organic biomass. We can tell this for a certainty because of the chemical signatures that come with it. When a primeval biome got buried and transformed into oil over millions of years, pure hydrocarbon fuel is not what was left over. It's full of the other chemical biomarkers that tell us whether that was a swamp full of plants and algae, or an inland sea full of plankton and prehistoric megafauna. They broke down into the chemicals of life, such as chlorophyll and hemoglobin, and left us biomarkers such as pristane, phytane, steranes, triterpenes, and porphyrin, among many others. This is why there is no question that if abiogenesis does take place, it does so on a very small scale, small enough that we haven't found any of it yet. It is not a pseudoscience, so long as it's kept within known bounds. But most of the proponents of abiogenesis argue that it is responsible for all oil, or most oil, or that we have a limitless supply from the depths of the earth, constantly regenerating itself. This perspective, distinct from the plausible version, is pure pseudoscience, as it's trivially disproven on a lab bench with a mass spectrometer and any sample of natural crude oil from anywhere in the world. Geophysicists do have good reason to reserve a reasonable amount of hope that limited abiogenesis does take place, however. There are some compelling lines of evidence. Among the most often cited is that some hydrocarbons, most notably methane, are found on other planets in the solar system, planets that lack Earth's history of diverse, abundant life. The gas giant planets all have substantial methane in their thick atmospheres, along with other hydrocarbons. Titan, in particular, the largest moon of Saturn, is awash with methane. It flows in liquid lakes and rivers covering about 2% of the moon's surface, and it makes up almost 5% of its nitrogen-rich atmosphere. Enceladus, another of Saturn's moons, was visited by the spacecraft Cassini which flew close enough to sample geysers of water that jet out into space, and found that water to contain trace organic chemicals. We've even detected methane in the atmosphere of Mars. It would seem that our own solar system provides ample evidence that hydrocarbon fuels may indeed create themselves on our worlds. It's not new news. A 1935 paper in the AAPG Bulletin, the American Association of Petroleum Geologists, reported these spectroscopic discoveries in the solar system with enthusiasm, as the implication could be that vast stores of primordial hydrocarbons might be on Earth too. However, the paper was careful to qualify this hope, noting that convincing evidence has not yet been presented to prove that commercial accumulations of petroleum and natural gas have originated from such a source. That assessment hasn't changed. In the 8 decades since that paper, we still have no evidence of abiotic petroleum or natural gas on Earth, much less commercial quantities of it. But what we do have is better insight into the origins of those hydrocarbons in the solar system. Although we don't have proof or a complete picture, it does seem that these compounds are the result of chemical processes on these bodies. Methane doesn't last long in the atmosphere. It gets split apart by solar radiation and oxidized in some atmospheric environments, so there has to be some source constantly producing it on all these bodies. Some of it does come in from comets, but not enough to explain the observations of its amount and distribution. Microorganisms are a possibility, unproven of course, but consistent with the observations. Titan provides the most telling example, as it has by far the most methane and is missing the other chemical signatures we'd expect if microorganisms existed there. What it does have is the right geochemistry for a process called serpentinization. Serpentinization is a hydrogeochemical process in which water, in the presence of metallic minerals which act as a catalyst, splits and produces hydrogen, which in turn reacts with carbonaceous minerals to produce methane. This is the leading candidate for what we observe on Titan, Enceladus, and Europa. Serpentinization also happens here on Earth, though at slow rates that don't produce enough to keep up with the resultant methane's obliteration in the atmosphere. In commercial processing of hydrocarbon fuels, a dizzying array of chemical processes are employed. We won't even go into these because there's so many of them and most of them are really complicated. They include the Fischer-Tropsch process, spinel polymerization, graphite synthesis, kerogen hydrogenation, carbonate decomposition. There are countless possible chemical reactions, many of which plausibly can and do happen in nature under the right conditions, deep underground with extreme temperatures and pressures. The greatest proponents of abiotic oil have been a core of Cold War-era Soviet scientists, whose Russian successors continue their work today. Their position has been that most or all oil on Earth is abiotic, and promote what they call the deep abiotic petroleum hypothesis, in which there exists a virtually limitless supply of oil worldwide, very deep underground. In the 1970s, astrophysicist Thomas Gold brought a variant called the deep gas hypothesis to the wider attention of the Western public. Since Gold's death in 2004, the primary Western voice has been that of Jack Kinney, who espouses the Russian view, and spends at least as much time promoting abiotic oil as he does posthumously accusing Gold of plagiarizing his Russian colleagues. Gold was an interesting guy, probably one of the more interesting you'll ever encounter. He was bright, charming, witty, made friends everywhere, and could hold an engaging conversation with anyone on any subject. He was Tommy to all who knew him. Nominally, he was an astrophysicist, but his work extended into many other fields. He made significant contributions in aerodynamics, in human hearing, and in the panspermia hypothesis of the origin of life. During World War II, he worked on radar systems, and was among the first to propose medical sonograms. Later he worked in radio astronomy and was a co-creator of the steady-state theory of cosmology, which enjoyed status as a major theory for years, until it was supplanted by the Big Bang. On top of all this, he was also a competitive skier. Gould had no doctorate degree, probably because he was so often bouncing around from one field and one profession to the next. By necessity, this meant that he was often working outside the mainstream and in a state of isolation from the experts in that month's field of choice, a minefield for any scientist. This going it alone, without checks and balances, is a process that's a breeding ground for crank theories. Yet throughout his career, Gould used this to his advantage, prompting physicist Freeman Dyson to write in the foreword for one of Gould's books, "Gould's theories are always original, always important, usually controversial, and usually right." It's that usually part wherein lies the rub. It's in our nature to root for the maverick and to seek out what's new and exciting, and we tend to forget that usually right means sometimes wrong. And all indications are that Thomas Gould's devotion to abiotic oil was just such a case. There is a final wrinkle to the story of abiotic oil that brings a discredited idea into perspective. It is one of ideology, one in which we ask, why would a large body of scientists, mostly Russians, promote an idea that is clearly disproven by a century of large-scale commercial oil production? Note that the Russian idea holds that these limitless supplies are deep, deeper than we can easily reach today, and much deeper than could be reached in the middle of the century when this theory was developed. This made it an unfalsifiable hypothesis. When we look at what was happening in the Soviet oil industry in those days, we find that it was struggling. Today's Russia has plenty of oil, but it's hard to reach. Much of it was virtually impossible to reach with Cold War oil technology. The Soviets were in an oil crisis. Under threat of the loss of such an important resource, the Soviets were ideologically welcoming to an idea that suggested oil would always be plentiful for all and inexpensive. They were correspondingly hostile to actual oil science that showed oil would become increasingly scarce and expensive. Thus, the combination of a geologically plausible idea with a highly attractive ideology gave abiotic oil a powerful foothold among Russian scientists. We can infer that it's probably likely we'll see continued support for the idea among other groups who would like to see oil remain plentiful and cheap, even among those to whom conspiracy theories appeal. Kinney's website even has a whole section of articles accusing biogenic fossil fuel of being a conspiracy cooked up by the media and corporate interests. And so, while lab bench analysis continues piling on the evidence every day that all of Earth's oil is biogenic fossil fuel, a pseudoscientific idea continues living on, and will probably continue doing so into the foreseeable future. As in so many other cases, the real key to the pseudoscience lies not so much in the specific claim, but in the ideology and historical context. As conspiracy theories go, this one is pretty tame. You want to hear some real conspiracy theories? Want to know the complete history and facts behind 50 of the world's greatest conspiracy claims, from the moon landing hoax to chemtrails to the claimed mind control dangers of fluoride? I'm talking about my new book, Conspiracies Declassified, from Simon & Schuster. Order it now on Amazon.com or Barnes & Noble. Conspiracies Declassified. The truth actually is out there. You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com.